In this topic, we're going to cover an introduction to object-oriented programming. We'll be covering these object-oriented programming topics practically, but first, let's have an introduction into object-oriented programming, or OOP. So far with our scripts, we have been implementing procedural programming. We defined data and functions that operated on that data, but the data and functions are mostly decoupled. Our scripts have been simple and straightforward, but as our applications grow, we run into limitations, especially around maintainability. If you've ever found yourself copy and pasting the same code into other places within your scripts, a well thought out object-oriented programming approach can help prevent that type of maintainability problem which comes paired with this spaghetti code. Object-oriented programming groups variables and methods into objects. Object-oriented programming structures software into reusable blueprints called classes, and these blueprint templates can be used to create objects by instantiation, and these class objects can contain data as an attribute, and they can also contain functions as methods. So for example, let's say we wanted to create a person class. We could structure a person's information as a number of lists, for example, but as the information changes and becomes more complicated, simple structures such as lists become much more difficult to manage and maintain. Instead, we could create a person class as the blueprint, and this class might contain a name as an attribute and a sayName function as a method, and we could instantiate different objects. For example, we could instantiate both Bob and Alice as instances of the person class. And once instantiated, we can use the accessible methods and attributes for that individual instance. So Bob would be a person object with a name which can be said, and Alice would also be a person object with a name which can also be said. And each instance is separate. So Bob is not Alice. However, both Bob and Alice are person objects. And one of the benefits of object-oriented programming is that it allows us to group related information together to make code shorter and easier to maintain by reducing complexity, which ultimately saves time as applications grow in both size and scope. And object-oriented programming also enables us to leverage existing structures, which is known as inheritance. It also enables class-specific behavior, which is known as polymorphism. We can also secure and protect attributes and methods, known as encapsulation. And object-oriented programming is also extendable and modular, which is known as overloading. And we'll go over each of these concepts as part of practical examples as part of this course. But that's it for now, and in the next lesson, we're going to cover classes, objects, and methods.